You should have a copy, a blank copy of these notes to fill out as you watch this video, period. If you do not have it, please email me and I will send it to you, period. Here we are reviewing ratios and proportions. The word ratio is just meaning the comparison of two quantities, and they can be written three ways: with the word to, with a colon, or as a fraction. Ratios can be written three ways right here: 3 to 4, 3:4, or as a fraction, 3:4. Proportions are a statement that you have two equal ratios. Basically, the word ratios mean fractions. We're looking at this form here. So A over B equals C over D is a proportion because of the equal sign. And we can solve these by cross multiplying. This is where you may remember doing that, where you multiply these diagonals by each other. So A times D here equals B times C, the other diagonal. We don't need to be too concerned with the definitions here, but A, D are called the extremes. B and C are the means. The product of the extremes equal the product of the means. Let's look at something that we know is a proportion, meaning we have two equal fractions. Here we have 3/4, and we know it is equal to 6 over 8. So if we multiply the top and bottom here by 2, we get 6 and 8. So these are two equal ratios, therefore it is a proportion. So this is where we are saying if we multiply the diagonals here, 3 times 8, it will also equal the other diagonal, 6 times 4. Here we have 3 times 8 equals 4 times 6, and 24 equals 24, so we know it is a proportion. 24 equals 24. If those diagonals did not equal each other, then the original two ratios are not proportional. So here we have a question. Is this a proportion? 16 points in 5 games compared with 11 points in 3 games. Basically, we're just going to multiply the two diagonals here, and if we get the same number, they are proportional, meaning the same amount of points were scored per game. So the question is, does 16 times 3 equal 5 times 11? The diagonal. 16 times 3 is 48. 5 times 11 is 55. They are not equal. That's the equal sign with the slash through it. So no, this is not a proportion. Here is a very standard proportion question. Solve for the variable in this proportion. We are being told that the one fraction does indeed equal the other one. So we know that 15 times n has to equal 10 times negative 12. So this is where we are able to cross multiply because of the equal sign. All right, so 15n, this diagonal, equals 10 times negative 12, so it's a positive times a negative, negative 120. And we are going to divide both sides by 15 to solve for the n. Here I divided both sides by 15. That gives us n equals negative 8. We have n equals negative 8 because we have a negative divided by a positive. A word of caution here. You need to be careful of when you can cross multiply. If you just have multiplication of two fractions, we do not cross multiply there. So here we have 3 over 7 times 5 over 6. We would not do 3 times 6 here. To multiply fractions, we go straight across. If anything, we could reduce the 3 with the 6 first and then multiply straight across. The only time you can multiply diagonally here is if we have an equal sign in there. So just finishing this out, we could just go straight across. 15 over 42, and both of these will divide by 3. So 15 divided by 3 is 5, 42 divided by 3 is 14. Problem 3. A survey of mathematics faculty at Wasamata University indicates that 15 faculty members are registered Democrats and 21 are registered Republicans. Find the simplified ratio of Republicans to Democrats. So we're just looking to compare Republicans. There are 21 Republicans and 15 faculty are Democrats. So 21 to 15. So here we have 21 to 15. We are just going to use the fraction form, but you could use a colon. And this does say simplified ratio. So we need to reduce this. These will both divide by 3, ending up with 7 to 5. Part B, find the simplified ratio of Democrats to total math faculty. 15 faculty are registered Democrats. So we have Democrats are 15. Total math faculty. We aren't given the total. A survey of the faculty indicate that 15 are Democrats, 21 are Republicans. So 15 plus 21 gives us the total here, which is 36. So 15 Democrats to a total faculty of 36. These can both divide by 3, which is 5/12. So it means there are 5 Democrats to 12 total faculty. Take a minute to read problem number 4. You can pause the video. So the question is to find the ratio of gasoline to oil in the proper mixture. We need to compare the gasoline to the oil in the same quantities, the same units of measure. The gas is measured in gallons and the oil is measured in ounces. So I'm giving you a conversion here. 1 gallon is equivalent to 128 ounces. So we are going to convert the gallons to ounces so we can get a ratio in the same units. So first, the 5 gallons, there's 128 ounces per gallon, so we're multiplying to get a total of 640 ounces for the gas. So now we are comparing our ratio of gas to oil. Understanding the labels when you're doing ratios and proportions are important. So we're comparing the amount of gas to oil. So the gas is 640 ounces to 40 ounces of oil. 640 ounces to 40 ounces. Technically here the ounces are going to divide out, and 640 divided by 40 is 16. So we say that our ratio is 16 to 1. And that does not have any units on it. It is just saying 16 parts of gas to 1 part oil. 16 to 1. So we say the ratio is 16 to 1. Take a few moments to read problem 5, which is a standard nursing dosage problem. So the question is, how many milliliters of solution should the nurse give to the patient? The given drug is available in a concentration of 50 milligrams of simethicone, the drug, per 0.6 milliliters. So we are comparing milligrams to milliliters. That tells us the labels out here in our two ratios. And this is going to be set up as a proportion because we have a given ratio that needs to be equivalent to a final ratio. So the 50 milligrams is our numerator, and the 0.6 milliliters is our denominator of the given, the medicine that's readily available. And we have to equal it to the 240 milligrams that needs to be given, and how many milliliters should the patient get down here. So that's our unknown. We've set up a proportion, so to solve this we will cross multiply. So 50x equals 0.6 times 240, if you multiply that, you get 144. So we are going to divide both sides by 50. (144) divided by 50 is 2.88. So X is 2.88 milliliters, our denominator label, and that is how many milliliters should be given to the patient. Please read the next question. So the two things being compared are people and time. I know you could solve this possibly without doing a proportion, but that is what we are practicing. So we will set up a proportion of people compared to time. So we have 32 people get on the coaster every 5 minutes. So that's 32 people every 5 minutes. And Mary Ann is the 272nd person in line. So how long will she have to wait is the unknown down here. So because of the equality, we can multiply diagonally. 32x equals 1360, which comes from 5 times 272. And we are going to divide both sides by 32. So here we have miles per gallon. So 18 miles per 1 gallon is equivalent to how far can it travel is the unknown, the top, and the 12 gallons given is the bottom. So to solve this simply, it's x equals 18 times 12. 18 times 12 is 216, and the top was our miles value, so 216 miles. The last part of our proportions unit is on similar figures. Similar figures are two shapes whose corresponding angles are equal. So angle B here is equal to angle E, A, D, and so on. As a result, their corresponding sides are in proportion. So being in proportion means that we can set up two equal ratios or fractions, and we'll be able to solve for it by cross multiplying. AD will equal BC. So given triangle ABC is similar to triangle DEF, find the length of the side labeled X, which is right here. So because they are similar, we can set up two equal ratios. And I am going to compare side AC to DF, and then BC to EF. There's other ways you can do it, but this is one of them. AC, DF, BC, EF. This is showing the ratio of the corresponding sides are equal, because AC corresponds to DF. You need to be consistent. You can't do it this direction here and then flip this around and be EF on top. So we're placing the values in the correct places. It's 13 compared to X equals 6 compared to 5.1. and we are cross multiplying. 6x equals 13 times 5.1, which is 66.3, and we're going to divide both sides by 6. Dividing by 6. X equals 11.05, and I put the word units on here because in the original problem, the 13 and the 6 and the 5.1, they didn't give anything like centimeters, inches, feet, so we just put the generic word units. In the figure below, triangles ABC, ABC, this small triangle, and ADE are similar. So the little triangle here is similar to the big triangle. So I highlighted the little triangle in yellow and the big triangle in green. Because those triangles are similar, their corresponding sides are in proportion. So I am going to compare the sides of the little triangle to the big triangle. So let's make sure you understand this. The little triangle side AB here is compared to the full long side of the big triangle AD, AB, AD. So for this one over here, we're starting with little triangle on top. BC compared to DE. And now we can fill in the missing numbers to look for our unknown side. Determine the length of side AB. This is the unknown, which is the x. So we have x compared to the full entire large triangle, which is the 15 out here, x over 15, equals little side here, BC, compared to the big side here, DE, which is 9. And we're going to cross multiply. 9x equals the product we get here. That gives us 9x equals 108, and we are going to divide both sides by 9. So x equals 12, and we did have an inches label in this problem, so that is the missing side. Now that you have finished the notes, there will be homework in Math Lab, so please look for that. And be sure to hand these notes in next class.